Alright, so good day. So we're going to continue our discussion on fluid flow measurement. And this time we're going to talk about gates and tubes. Okay, so gates, these are opening, okay, in a dam or other hydraulic structure to control the passage of water. So as the definition says, no, it's applicable to dams. So here are the examples or illustration regarding it. So here, no, on the right side of your screen, you're going to see the free-flowing gate wherein, okay, the gate is submerged only on the, let's say from the screen, the left side, no, okay. So the other one is what we call the submerged flow, wherein both sides of the gate have their fluid, okay, and the gate is submerged both sides, okay. That's why it's called submerged flow. So the principle of gate applies or have the same principle when it comes to the orifice, no, the hydraulic properties. So in using the gates, so we have also to calibrate the available devices so that we could also yield to accurate measurements. Okay, so we know because the gates are used in dams, so that we cannot control the amount of water that will be poured into dam. So, for example, the rain, the flooding, okay, we cannot control that, but we could control the fluid that will flow on the gate. Okay, that's why we have to calibrate it and to have this value for the discharge and the velocity. So that's why we have this coefficient of velocity and the coefficient of discharge. Also, in line with that, we also have the coefficient of contraction. Okay, so in relation to the velocity, we have this formula of the theoretical velocity. Of course, uh, velocity here is equal to square root of 2g multiplied by d sub 1 minus d sub 2 plus v sub 1 squared, and the actual velocity will be multiplied by this one, okay, to the theoretical velocity. And so, for us to derive the formula, so let's have this illustration back again. Okay, actually this is both for the free flowing and submerged. So this is, I think this is the free flowing and this is the submerged. So we could use this both, no? Actually, so we could have the equation. Okay, most of the time naman, no, in hydraulics, no, even if it is submerged or free flowing, we still use the same uh, principle. But this one, no, we use the free flowing, not to derive the formula, because it will be applicable naman to the other side, wherein z is the, or z sub 1 minus z sub 2 is the h that you see on the submerged part, this one. Okay? So, ayan po. So, now, let's derive the equation for the theoretical velocity. Since it is theoretical, okay, so, from our previous discussion, we use the ideal Bernoulli's energy equation, that is E sub 1 is equal to E sub 2. This is the ideal Bernoulli's energy equation. So, that is V sub 1 squared over 2G plus P sub 1 over gamma plus Z sub 1 is equal to V sub 2 squared over 2G plus P sub 2 over gamma plus Z sub 2. Okay? Here in this scenario, P sub 1, using this free flowing, actually P sub 1 over gamma is equal to D sub 1. And on the other hand, P sub 2 over gamma is equal to this one, D sub 2. So these are the potential energy heads or the pressure heads. So by substituting this one to the Bernoulli's energy equation, it will become V sub 1 squared over 2G plus P sub 1 over gamma plus Z sub 1. So we know that P sub 1 over gamma will be, it will become D sub 1. Okay? It will become D sub 1 plus Z sub 1 is equal to V sub 2 squared over 2G plus D sub 2, this one, plus Z sub 2. Okay? So since both in this free flowing, no, if we took the point wherein our z sub 1 will be equal z sub 2, no? So for the velocity at this point, no? This is point 1, this is point 2. Therefore, if we have the same datum, z sub 1 is equal to z sub 2. So actually we could cancel it out. So we'll have, okay, or it will become 0 depending upon on the datum. So we could have what? We could have this equation now reduced to this one. V sub 1 squared over 2g plus d sub 1 is equal to v sub 2 squared over 2g plus d sub 2. Okay, so transposing both like terms, okay, so it will become v sub 1 squared over 2g minus v sub 2 squared over 2g is equal to d sub 2 minus d sub 1. Okay, so this is our equation. Okay, so or changing the sign so that we could apply the concept of Venturi principle, no, the increase in kinetic energy is equal to the decrease in potential energy. Therefore, we change the sign, no, instead of this as negative, so let's change this one to negative, then this is positive, right? So this one is negative d sub 2 and this is positive d sub 1. Therefore, we could have the b sub 2 squared minus b sub 1 squared is equal to 2g multiplied by d sub 1 minus d sub 2. Okay, so we all know that v squared, v sub 1, v sub 2 squared minus v sub 1 squared is equal actually to actual velocity. Okay, so, or should I say theoretical velocity since it's ideal. Okay, so it will become this equation. Okay, so v squared, it will become v squared. So v squared is the square root of this one. That is the theoretical velocity. Okay, which is also the same to the one that I presented. Okay, so the equation above this one, no, the theoretical velocity. Okay, so that is for our equation. So therefore, the total discharge or the actual discharge is the theoretical velocity multiplied by c or coefficient of discharge, and the coefficient of contraction, this one is c sub c is equal to d sub 2 over y. That over y is going back to the free flowing. This is d sub 2, okay, over y. Okay, that is the coefficient of contraction because there will be slight deviation, no? If you could see this one. Ito po. Yan. This is the slight deviation or delta y, no? Wherein the gate will be, or the jet contracts, no? As it leaves the gate. Okay? So that is for the coefficient of contraction. So now, okay, so in this case, no, C is equal to C sub C multiplied by C sub V. We all know that, no? But this, we have been given that it varies from 0.61 to 0.91. We also have A, the area is B multiplied by Y. So B is the width of the flume or the gate. So that is for B. And Y is the distance, okay, from the gate to the ground, no, or the surface. It's going back to the illustration, this one. Okay, so that is for our equation, okay, or the unknowns in the formulas. Okay, that is for the gate. Okay, now let's move with the tubes. Okay, so under tubes, first we have what we call the standard short tubes. Okay, so in standard short tubes, so is a tube one with square cornered entrance and has a length of about 2.5 times the what we call the internal diameter. Okay, so in the figure now on the left side, it shows of what condition when the flow started suddenly with high heads to the jet, no, that may not touch the walls of the pipe. So as you observe here, no, hindi nga nag-touch, no. Ito, mo may separate, no, na area. I colored it green, right? So between the gate and the jet, no, hindi siya natatouch, no, those standard short tubes. Therefore, the length is, no, as stated, is 2.5 the diameter. So that is for the left side of your screen or the left uh, illustration. Okay, so it is the same almost with what we call sharp crested orifice. That's why we have this what we call the coefficient of contraction. Okay, so the right side of your screen, no, or illustration, the right illustration is a condition when the jet touches the walls of the tube. Okay, but no, as you observe here, nag-contract siya at this point, no, at this point. Ito. So I will color this green. So ibig sabihin that means there's a contraction, this one, but it will eventually touches the wall. So that's why meron siyang coefficient of contraction na equal to 1. Okay, and the coefficient of discharge, this one, is equal to the coefficient of velocity, which is 0.82. Okay, so the pressure at this point, or P sub A, is 0.82 H. Head, H is the total head, and the velocity, nominal velocity, 0.82 square root of 2gh, or this is what we call the actual velocity, because it's multiplied by the coefficient of velocity. Okay, so that is for the standard short tube. Okay, so next on the tubes we have the what we call the converging tubes. Okay, so in converging tube, this is our conical, no, in conical converging tubes have the form of a frustum of a right circular cone with a larger end adjacent to the tank. So for example, this side, no, is the tank or a reservoir, no, this one, no, tank or reservoir. So this angle of convergence, no, is on the side of that. So parang frustum nga ng ating right circular cone. So here we have the table, no, on the angle of convergence in relation to their coefficient. So don't need to memorize this one because it's, as I've like said before, no, we could actually compute this one, no, the coefficient. If there's a specific angle of convergence given, so the C sub C or C sub V, or either one of the coefficients, so between, I think it will always be between C sub V and CD or C. So we could actually compute for C sub C, okay, in relation to your orifice, no? Parang lang kasi hindi siyang orifice na nag-contract. Okay? So yun nga lang, nag-touch siya sa wall. So as you could see here, no, meron siyang ganito, no? So nag-contract siya sa portion na yan. Parang almost the same as the short tubes, no? Yun nga lang, may angle of convergence. Okay? So if there's a converging tube, we also have the diverging tubes, no? But before that, this is the formula, no? So the same actual velocity is, actually, this one is the theoretical, if you still remember, no? This is the theoretical velocity. And then, it will be multiplied by the coefficient of the velocity. So you will have the actual velocity. So therefore, actual discharge is the actual velocity multiplied by the area and the coefficient of velocity, or discharge rather, the coefficient of discharge. Okay, so that's the equation. So going back to what I'm saying, if there's a converging tubes, there are also diverging tubes. Actually, diverging tubes are similar to the converging tubes. Yun nga lang, the other side, pabaliktad, no? The angle is on the side of the release part, no? Ibig sabihin, doon nagkaroon ng paglabas na doon sa tank or reservoir. Okay, so that's why it's called angle of divergence. No, there's no table particularly on that, but it's like I said, it could be computed, no, applying the concept of device coefficients. Okay, so we could actually compute for that, no, that C is equal to C sub C multiplied by C sub V. So no need for memorization of values, no, or if it is specific angle, we could actually give it, no, to the, leave it to the computation. Okay, or the value should be presented just like this one. Okay, so we've done with converging tubes, we've done with diverging tubes. Now let's go to what we call reentrant tubes. Okay, so reentrant tubes, actually tubes have their ends projecting inside a reservoir. From the term itself, reentrant, sabihin babalik. Okay, so if there's a special case of reentrant tubes, no, what we call the Bordas mouthpiece, no. So it consists of a thin tube projecting into a tank having a length of about 1 diameter. Okay, so the coefficient of contraction for this tube is 0.5 and the coefficient of velocity is 1.0. So that is for Borda's mouthpiece. No, parang ano lang siya, reentrant tube na may specific nga lang na may thin projecting a thin tube projecting into a tank. So pabaliktad, no? So that's what we call reentrant. Okay? So babalik siya doon sa tank. No, as you could see on the arrow, ba, let's say this is the side of the tank or reservoir. So babalik siya dito. Okay? So ayan, given na yung mga values ng kanilang C sub C and C sub V. Okay, and next on that is what we call the submerged tubes. Kanina, we have illustrated that, no, yung the short tubes, but that is for the standard short tubes na naka-submerged. Okay, don't mistake it on that. No, it's submerged flow. Okay, we are pertaining now to tubes. Kanina gates, no. We have also the submerged. So in submerged tubes, actually one of the best examples, what we call yung mga culvert natin. So where do we find culvert? Actually in highways, no, wherein the highway traversing an ocean or maybe a river, no, no, not really an ocean, but part of, let's say, a bay, no, bay area. So we have this culvert, no, or a dam or a dike rather, di ba? Pwedeng dike, no, or an embankment to a certain bodies of water. Meron siyang culvert so that the water could actually go in or go out on both sides of the uh, where the dike or the embankment or the dam, no, somehow parang dam na meron, or should I say dike na merong culvert, no, could actually free flow, no, para in relation to the environmental concerns. Okay, so the discharge, no, actually this is what we call the actual discharge, no. This is actual discharge. So the same thing with other formulas, no? This square root of 2gh is the theoretical velocity. Okay, theoretical velocity. This one is the area, of course, and this is what we call the coefficient of discharge. So, ano lang, A is equal to times the velocity, di ba? So, ganun pa din siya, the same. So, mas madali nga lang because the area we know na if it is a culvert, now the diameter from the other side of the culvert is the same as the other one. So, applying the concept of Bernard's energy equation, if there's a height difference between the two side, so this H is, we know, this one could be what? No, this is the head, or the total head. No, we could actually compute this one, no, or this is what we call the difference in elevation, that is d sub 1 minus d sub 2. Okay, so that is for our culverts, no, or tubes. So now for us to appreciate these formulas, no, let's apply these formulas on sample problem. Okay, so let's have this problem number 8. So I gave you problems number 1 to 7 on the part 1. Actually, we still have this part 3 now because of the topic coverage. Now we will still have the part 3 of this discussion on fluid flow measurements. But going back on this problem, now this is about the gates and tubes. So let's answer this problem. It states here that a concrete culvert 1.2 meter in diameter and 5 meter long conveys flood of water. Both ends of the culvert are submerged and the difference in water level upstream and the downstream is 2.4 meters. Calculate the discharge assuming C is equal to 0.61. So this is our problem. Now from the problem itself, mukhang ito ay culvert, no, agad. So to visualize the problem, ito, we have this illustration here. So it states in the problem that kung meron daw siyang diameter na 1.2 meter and makalagay na dyan, and 5 meter long yung ating culvert. So tinatanong sa atin sa problem is the discharge. No, actually the discharge here is actually the actual discharge since we have been given the uh, coefficient of discharge. So we could actually answer this directly. Now let's write first the given. So for the given, we have been given the diameter of the culvert, that is 1.2 meters. Ayan, nakalagay 2 meters. So we could actually compute for the area. Okay, so what else? Now on the problem, so we have the 1.25 meter long. So we have the level of the downstream in relation to the upstream. No, parang from the upstream to downstream, we have been given 2.4 meters. So in short, this is actually the z sub 1 minus z sub 2. So that is equal to h. Tama? So that is 2.4 meters. What else, no, from the problem? So we still have the C, or the coefficient of discharge, as 0.61. So actually we could directly compute this one using the formula on the discharge. Now to solve, so this is actual discharge. So we know that actual discharge, applying the coefficient of discharge, is Q, or Q sub A, is C multiplied by Q sub T. So Q sub A, or Q, is C multiplied by the area multiplied by square root of 2gh, or the theoretical velocity. Q sub A is C, 0.61, multiplied by the area, that is pi over 4, multiplied by the diameter, 1.2 squared, okay, meters, okay, a square meter. So multiplied by the square root of 2gh. So that is square root of 2 times 9.81 times the height, or the difference in elevation, that is 2.4. So Q sub A is equal to, we have the value of 4.734 cubic meter per second. Okay? So this is the answer for this problem. Ayan. So uh, just a culvert, no? So that means the area here, no, that we are having here, no, the area actually is the area of the culvert. So since yung diameter naman ng culvert natin ay isa from the left side to the right side, so yun lang yung area na yun. Okay? So if the problem will be if the elevation of both sides will be given, so in short, yung h natin will be the difference. Okay? So that's it. If the problem requires us not to find for the actually the actual velocity, for example, we could actually compute, no? For example, we are required, no? Additional lang to. We are required to find actual velocity. Okay? Since we have the theoretical velocity, and since we have the theoretical velocity, no, that v sub t is equal to square root of 2gh. So let's compute v sub t, square root of 2 times 9.81 times 2.4. Okay, so v sub t, we could compute that. That is square root of 2 times 9.81 times 2.4. It will give us an answer of 6.862. No, yeah, let's for the sake of discussion, we use 3 decimal places. Yeah. So since we have this one, and from the problem, no, we have the coefficient of discharge. Okay, so for example, we have been given, no, the C sub V, bawal lang. No, we have been given C sub V. for the sake of discussion, so let's say C sub V is given as 0.85. Okay, so let's multiply this to 0.85 so that we can actually have actual velocity. Okay, so that is now to if given, if it is given, so therefore V sub actual is C sub D V theoretical. So that is V sub A is 0.85 multiplied by 6.862, or V sub A is equal to, or if you don't round up the answer, so just multiply it in 0.85, or if you don't round off the answer, that is 5.833. 5.833 meter per second. Okay, so that is only for additional. Okay, if it is given. Okay, so next we have this next problem, a problem number 9. So it states here in problem number 9, it is desired to divert 5.1 cubic meter per second of water from the pool whose water surface elevation is 45 meters to an adjacent pond whose water surface elevation is 42 meters by means of a short concrete culvert 8 meters long and with both ends submerged. What size of a culvert is needed, assuming C is 0.58? So this time, it's the other way around. So for us to visualize, so mga ganito ipagkakasabi sa problem. So we have here the other side of the culvert or the pool, no, to the pond. So the elevation of the pool, no, from the water surface is 0.45, while the elevation on the side of the pond is 42 meters. So ito po, no, 42 meters, and this one is 45 meters. So given, no, from that, no, just like I've said, if this is the C sub 1 and this is C sub 2, therefore this 3 meters here is the H, no, that is C sub, this is C sub 2. C sub 1 minus D sub 2. Okay, so applying the formula a while ago, so that is, so let's compute, no? So meron tayong given na H, okay? So what else, no? The problem, we have the discharge. Actually, this discharge, the desired discharge here is what we call the, ano kaya to? This is actually the actual discharge because this is the desired, no? The actual discharge. So we are asked to find for the diameter of the culvert. Okay. So from the equation, so let's apply the equation. So but first let's have the given. So given, we have the diameter as unknown. Okay. So we have the discharge. Actually, this is actual discharge. From the problem states that 5.1. So 5.1 cubic meter per second. So we have the H, no? That is E sub 1 minus E sub 2 from the illustration. We have that 3 meters. So what else? We have the C, or the coefficient of discharge. That is 0.58. Okay. So you can actually compute, no? That is Q sub A is equal to C multiplied by the area multiplied by square root of 2GH. Okay, so let's meron tayong given na discharge that is 5.1 is equal to C 0.58 multiplied by pi over 4 multiplied by D squared. No? Since ito yung pinapahanap sa atin, yan. Okay, multiplied by square root of 2 times 9.81, and H here is 3 meters. So, doing the equation or simplifying the equation, we have the diameter equal to 1.21 meters. Okay, so this is our answer for this problem. So, just like I've said, now culvert area or diameter is the same whether from the upstream or to the downstream side. So this is the diameter of the culvert. No? Required to what? To have a desired discharge of this one, no? 5.1 cubic meter per second. Okay? So that is for our culvert diameter. Okay? So if the problem requires you to have additional unknowns, no? So halimbawa, we are asked to have the theoretical velocity, we know how to compute. Or if given nga yung ating mga, for example, given yung coefficient of discharge, then we are asked to have the coefficient of contraction. So we know that uh, coefficient of contraction could be given. Okay, so may binigay, and then we have this application of somehow culvert slash orifice, no? C is equal to C sub C multiplied by C sub B. Okay, so pwede na ma-compute yung iba mga actual values, okay, especially the actual velocity. Okay, so that is for our problem number 9. And for the last problem for this topic, we have this one. No? So it says here that the sluice gate flows into horizontal channel. Determine the flow through the gate per meter with when y is equal to 1 meter and v sub 1 is 6 meter. Assume that the pressure distribution at the sections 1 and 2 is to be atmospheric and neglect friction losses in the channel. So use the coefficient of contraction C sub C 0.85 and coefficient of velocity as 0.95. So this is the illustration. So ganyan. So from this, no, we could actually see that this is a free flow gate. Okay, this is a free flow gate. Okay, so we've discussed the formulas kanina a while ago. So we could actually answer this question. So let's use this illustration to write the given. It says here that y is 1 meter. So this y is 1 meter. So this is 1 meter. What else? We have the value of d sub 1. Now we have d sub 1 as 6 meters. Ito. So d sub 1 is 6 meters. So what else? Ano pa nakalagay sa problem? So section 1 is to be atmospheric. So P is equal to 0. Okay? So walang pressure. Ano pa? Or the D sub 1 is may kinalaman sa ating gamma. Okay? So let's see. Okay, so let's compute. Given yung C sub C as 0.85 and C sub B is 0.95. Okay, so let's write it here. C sub C is 0.85 and C sub B is 0.95. So let's compute. No? So from the idea of gates, no, kanina, we've discussed that when gates are actually for application of dam. Okay, so we could actually compute using the equations nung kanina, the equations of Bernoulli energy equation. But this time, since stated in the problem that it is atmospheric, so we don't have any change in pressure head. Tama? So that means the assumption is somehow P sub 1 and P sub 2 are both equal to 0. Okay? So reducing the formula, so kanina we have this formula, going back to the Bernoulli energy equation, E sub 1 is equal to E sub 2, therefore it is an ideal, so we're expecting na, theoretical. So let's rewrite B sub 1 squared over 2G plus P sub 1 over gamma plus D sub 1 is equal to V sub 2 squared over 2G plus P sub 2 over gamma plus D sub 2. The problem stated a while ago that the atmospheric, the pressure is atmospheric, therefore P sub 1 and P sub 2 are both equal to 0. So wala na to. Cancel na natin. What else, no? From the problem, ano pa kaya ang pwede nating makita doon? Okay? So actually we could have the value of what? D sub 2. Okay? Coming from what? Di ba mayroon tayong D sub 1? So But the value of d sub 2 will be coming from what we call the coefficient contraction formula. Okay, just remember this one. So C sub C is equal to d sub 2 over y. Okay, so d sub 2 over y. Assuming this is what for free flow. So C sub C is 0.85 is equal to d sub 2 over y. Y is 1 meter. So d sub 2 is 0.85 meters. So if there's d sub 2, okay, so you could actually have the what? The difference, no? Actually, we have the difference or P sub pressure, but since assumption atmospheric, mukhang diretso na to sa height, no? If we are talking about the height, no? But if the problem states that the pressure atmospheric, no? So we could actually use, no? Or should I say, neglect the losses. That's why, no? The application of P sub 1 is equal to P sub 2 is equal to 0 will be neglected since or should I say will be neglected since what the friction is neglected. So babalik tayo dun sa that this one, that P sub 1 and P sub 2, or should I say P sub 1 over gamma is D sub 1 and P sub 2 over gamma is D sub 2. So why? Because neglecting friction losses or head loss. Tama ba? So, that means, ang makakancel talaga natin instead of this one is this one, yung dalawa. Okay? Sila kasi mag-form ng head loss eh. Okay? So, that means, if going back to the equation, that is, so, it will become, so we could actually deduce this from v sub 2 squared minus v sub 1 squared over 2g is equal to d sub 1 minus d sub 2. So, therefore, this is v sub 2 squared over 2g. Yan, minus v sub 1 squared. Yan, 2g is equal to d sub 1 given, okay, that is 6 meters, and d sub 2 computed, 0.85. So, 6 meters minus 0.85 meters. So, we have this value of v sub 1 squared minus v sub 2 squared minus v sub 1 squared is equal to, reducing the equation, that is 101.043. Okay, so 101.043. The problem asks us to compute for what? We are asked to compute for flow through the gate per meter. So, the discharge, we are asked to compute for the discharge, and that discharge is what? That is actual discharge. So we have this from the idea of continuity equation, ba? So coming from this, we could actually say that, so ito, mani-neglect natin to since neglecting friction losses, so it will become P sub 1 is equal to D sub 1 and P sub 2 is equal to D sub 2. Yung ating Z ang mawawala, no? Yun ay mawawala. Okay? Because of friction losses. So, from the idea of continuity equation, we could actually say that Q sub 1 is equal to Q sub 2. Nag-iba lang yung openings, no? Tama naman, because the amount of discharge here, yung madi-discharge dito, is equal din naman sa madi-discharge dito sa kabilang side, no? So, going back, from the continuity equation, that Q sub 1 is equal to Q sub 2, therefore, we could actually have the computation of the area. Diba? So, we are asked to have per meter length, of the discharge that is equal to, lalabas na, that is 6 multiplied by area, na 1 meter. Yan. So, this is for the area, multiplied by what? The discharge, or should I say velocity, V sub 1, is equal to the area of the other side, that is 0.85 multiplied by 1 meter. Why is it that we are using 1 meter? Because we are asked to have the flow rate per meter width. Ito yung naging keyword dyan. Per meter width. Okay? So that is B times Y. Tama ba? Base or width of the flume or the gate. So yan. Multiplied by V sub 2. So we have this 6V sub 1 is equal to 0.85 V sub 2. So let's go back to kanina equation. V sub 2 squared minus V sub 1 squared is equal to, what is that? 101.43. So 101.43 meter per second. So using those two, or 141.043 rather, is 101.043. So equating these two, so we could actually have the values of we could actually have the values of V sub 1 and V sub 2. Okay? So V sub 1, so we have, or should I say V sub 2, we will be having the value as, okay, from equating this equation. Actually, what we need is V sub 2. Tama ba? So because we are asked to find the discharge at the gate. So equating this one, so V sub 2 is equal to, I think this is equal to 10.154. Okay? So that is equal to 10.154 meter per second. So we have the discharge, no, dito na lang. So equating for the discharge, Q is equal to AV. Now the question is, what is this discharge? No? Q is equal to AV. This will be equal to what? Velocity theoretical. Now, for us to become actual, no, or Q na lang, so we have to multiply the velocity V sub 2 to the coefficient of velocity. So, given yan na 0.95, no, kanina, ito, nabanggit natin, ayan. So, for us to compute for the discharge, actual discharge, no, Q is equal to area. What will be the area? Or the projected area? Area is 0.85 times 1. No, because that is the area, no, ito for V sub 2. Ito, diba? Ito yung kanyang area. So, it is 0.85 times 1 times the velocity, but we have to multiply for C sub V na 0.95 times the velocity na 10.154, or the value of discharge, no, actual discharge from the gate is equal to 8.2, no, round off na lang to, 8.2 cubic meter per second per meter length, or per meter width rather. Okay? So, this is our answer for this problem. Now, wag malilito na, sir, per meter pala, dapat square meter per second. No, we are asked to find the discharge per width of the flume or the gate. Okay? So, that is the answer for our problem, or this specific problem regarding gates. Okay? So, I think that those problems will help you to understand, no, the concept of gates and tubes. No, actually, the concept of gates and tubes are related somehow with your previous discussion on the device, no, or the device coefficients and the other measuring devices. Okay, so that's it for our part 2 ng ating discussion on the fluid flow measurements. Still have the part 3 regarding the open channels, or should I say, on the weirs and unsteady flow. Okay, so that's it for our discussion for today.